In this video we look at how to adjust the output of the ALU operator according to the required instructions. First, let's look at all the instructions processed by the operator. The values of ACC, B and CY are always passed to the operator, and the values of the sum and carry are always output. Depending on how it works, the following relationships arise. The original values are always transferred to the ADD and ADM, and the values of the adder are also output. The difference between the two commands is the source for B, but this is irrelevant here. The SUB and SBM instructions negate the source of B and thus calculate the subtraction. CMC and CMA calculate the non-value of CY and ACC here. IAC and DAC add 1 and -1 to ACC. RAL and RAR shift the bits of ACC and CY according to the rule shown here. We already know DAA and TCS from the last video. In today's video we'll just look at the results. We break the sum into its 4 bits. The first possible result is the result of the adder, to which we assign command line A. Options 2 and 3 are rotation to the left and right. The command lines for this are L and R. The last two possibilities are 9 and 10, which is the result of the TCS instruction. As we know from the last video, this depends on CY. We now translate this into mathematical equations that look like this. From this we can create this messy looking circuit. I created the 2 OR components with the 3 and 4 inputs offline. But you should have the knowledge to create these yourself. Give the inputs a value and now set the 4 command lines to one after the other and look at the result. If everything works well, we create another component that we call ALU result. The command line here is this. For the calculate method, we translate the circuit into Python code again. For the fast method we take the direct route again. At the end we build the circuit with the new component and test it. If everything works as expected, we can finish the video. In the next video we will do the same for the inputs of the ALU operator.